In this video we have three integrals to evaluate, and you could probably use the U-substitution in all three, but if you see something else, feel free to try it. So for the first one then, like I said, I'm going to use a U-substitution. You got pi there, that's a constant, so we could bring that outside the integral. And notice the square root of x here, you got the square root over here. So I'm going to let u equal to the square root of x. Then du will equal to derivative of this. Look at this as x to the 1/2 here. Square root of x is the same thing as x to the 1/2. So the derivative, we take the 1/2, multiply the coefficient, it gives me 1/2 here. And then we subtract 1 from the 1/2, the exponent. That gives me negative 1/2. And then this will be dx. Then I'm going to multiply both sides by 2. Give me a du out here on the left side, 2 du. Then I'll have a dx. Take this to the denominator, it becomes x to the 1/2, or the square root of x. So now we look at this over here. We got dx over the square root. So here we have it here. Dx over the square root. So let's convert this then to an integral involving u. The pi, we can bring it out here. It's a constant. And then we have e, and then the square root of x is the u. And like I said, this dx over square root of x, that's your 2 du. And the du will go over here. And again, we can bring the 2 out here. And we'll go ahead and do that. There we have it, 2 pi. There's a constant out here. E to the u, the antiderivative, or the integral of that is e to the u with respect to u. And then, of course, the constant comes along for the right. This is 2 pi plus the constant of integration. And then we go back to the original variable, x. It will be 2 pi e to the square root of x plus the constant of integration. And this is your final answer for that one. Okay, so the next one, if you look at the expression in the parentheses 1 over x plus 2, if you take the derivative of that, that'll give you x to the negative 2. So let's do this. U equal to 1 over x plus 2. Then du will equal to, again, think of this as x to the negative 1. So that'll be a minus 1 x to the negative 2. So the derivative of 1 over x plus 2 will give me negative 1 x to the negative 2, and this will be a dx. And we rewrite this as the integral of, so this x to the negative 2 dx, that's this, and this will be equal to du, actually equal to minus du, so let's multiply both sides by a negative. This becomes a negative over here. So all I'm going to do now is just replace the x to the negative 2 dx will be replaced by minus du. And of course this expression here will be u. And then that's to the 5th power. And I got my du. And then I've got a minus here from the negative du. Then we just integrate with respect to u. So we add 6 to the exponent, or add 1 to the exponent, we get u to the 6, and then divide by that. Still got the negative out here, plus the constant of integration. And then we go back to the original variable then. So got the minus here, and then the u is 1 over x plus 2. This is to the 6th power, and this is over 6. Plus the constant of integration. And that's your answer for that one. Right here. Okay, so for the third one, you got this expression here, and if you take the derivative of ln of x to the 5th minus 7, well, let's see what we get. So let's let u equal ln x to the 5th minus 7. So du will equal to Okay, the derivative of a natural log is you compute the derivative of what you have here in the parentheses, and then this is going to go to the denominator. Let's do it first. Let's do it like this first. So the x to the fifth minus 7 goes to the denominator, and then we take the derivative of that expression, and that goes in the numerator. So this will be 5 derivative of x to the fifth minus 7 will be 5x to the fourth. And of course, the derivative of negative 7 is 0, and then we have a dx here. So this is going to equal to, notice this part here over here. We can put these two together. The x to the fourth over x to the fifth minus 7 and the dx go together. And so if I break this up, then this part right here divided by 5 here, divide both sides by 5. So this expression then is equal to du over 5. So this will be the integral of, and then the ln of x to the fifth minus 7, that's the u. And like we said, this expression here, x to the fourth over x to the fifth minus 7 dx, that's your du over 5. So I'll put the 5 over here, where it is 1/5 du. Now we just integrate with respect to u. So it'll be 1 to the fifth, add a 1 to the exponent here, u to the first, add a 1, that'll be u to the second. That's over 2, plus the constant of integration. This is multiplied here. So this is going to equal to 1/10, and we've multiplied the 2 and the 5 here. And then the u is ln of x to the fifth minus 7. And then that's going to be squared. So I could put the square right here, or I could just put parentheses around this whole thing. Put the square right there. You don't want to put it here on the x to the fifth minus 7. So it either goes right here or there. And then plus the constant of integration. Thanks for watching. We'll see you next time.